We're on 12-3, trigonometric functions of general angles. This is a lot of information right here. This is like a ton of stuff, okay? Some of it you already know, some of it you don't know. So I'm just going to talk for probably like 5 or 10 minutes. You can just kind of watch me, and then we'll use this information when we get to an example. Do you have a question already? Theta? Theta just means an angle. Just any angle. Okay, they could call it X if they wanted to. They just typically call it theta. I think the reason they probably call it theta and not X is because sometimes you'll be looking for X, so they don't want to get you confused. It just means an angle we don't know. Okay? Okay, let's see here. So we're in an XY coordinate system up here. So you see, let's see here. Let's start with the ordered pairs. This is 1, 0. This is 0, 1. What would this one be? Negative 1, 0. 0, negative 1. That's not for you to understand what I'm talking about right now, but you at least know what those ordered pairs are, right? Okay? This is in degrees. 0, how many is this? 90, 180, 270, 360. Everybody okay? And then in radians, you could convert if you wanted to, but typically in whatever class you're going to next, you're going to have these memorized, because we really kind of memorized the 90, the 180, and the 270. Most of you probably weren't adding 90 every time, right? So this is still 0 radians. This is pi over 2. This is pi, 3 pi over 2, and 2 pi. So if you took your time and you did a conversion factor, you'd find out that every 90 degrees is another half pi. This is 1/2 pi. 1/2 plus 1/2 is 1 pi. 1 plus a half is 1.5 pi. That's what 3 over 2 is, right? 1.5 plus another half is 2 pi. So you don't have to memorize that in my class this year for sure, but next year you'll want to have those memorized. It'll be quicker. You don't want to convert all those to degrees every time. That'd be annoying. Okay? Quadrant angle. The terminal side of the angle in standard position lies on the x or y axis. I'll show you what that looks like in a second. Reference angle, the acute angle formed by the terminal side of theta and the x-axis. So this bow tie basically is what we're going to do. Whenever we do something, we figure out what quadrant it's in, and we draw that piece of the bow tie. So I'm not going to do all of these at once. I'm just going to do one little piece at a time so you see where it came from. So if I was drawing 30 degrees, okay? That's 30 degrees, right? I made it into a triangle. So you start at the origin, you go out, and you make it a right angle with your x-axis. So this is 30 degrees. And then I would use that information to find whatever I want. If I was drawing 120 degrees, this is 120, right? So then if I draw my triangle, so ignore this now. If I draw my triangle, what is theta? If this is 120, what's this? 60, right? Because it makes 180 altogether. So that's 60. So what we're doing here is we're figuring out the reference angle using these formulas. If it's in quadrant 1, oh yeah, we didn't talk about quadrants. 1, 2, 3, 4. That's from before though. Okay. So if we're in quadrant 1, theta is just whatever it is. Anything between 0 and 90 is going to be whatever it is. You don't have to do any math. Okay. If it's over here in quadrant 2, like we just were with 120, you take 180 minus the theta. So I did 180 minus 120 and I got 60. If it's in quadrant 3, you do theta minus 180. If it's in quadrant 4, you do 360 minus theta. And I'll show you how to use that in a minute. I don't want to do ASTC right now. I don't want to do axis trig right now. We'll come back to them. This isn't new to you either. We talked about special triangles the other day. You have a 45, 45, 90 triangle, and you have a 30, 60, 90 triangle. So just like the other day, these had x's on them. Today, we're going to put them in the coordinate system, so you don't need an x. You just need like a 1. So if it was x root 3, today it's 1 root 3, which is just square root of 3. So across from the 45s is a 1, hypotenuse is square root of 2. Across from the 30 is a 1, across from 60 is square root of 3, and hypotenuse is 2. Let's do some. Okay? The terminal side of theta in standard position contains the point -3, -4. Find the exact values of the 6 trig functions of theta. So I'm going to start off by graphing -3, -4. Everybody can do that. Are we good? Okay, great. That's in quadrant 3. So we're going to do that part of the bow tie. Whenever you do the bow tie, I don't know a better way to say it. You start at your origin. So here's the origin, right? You go to the dot, if you have one, and you make a right angle with the x-axis. So there's my right triangle. You guys see how that's the part of the bow tie that I need? Okay? So theta, is right here. It's always off the origin. So again, if you go back to that bow tie, see how theta is off the origin? Okay? So they want the sig trig functions. We have to fill in these sides. Okay? This is negative 3 because I want left 3. This is negative 4 because I went down 4. What is the hypotenuse of this triangle? We have a 3, 4, 5. You remember that? It's from geometry. Pretend it wasn't that easy. If it wasn't that easy, you would do Pythagorean Theorem. So negative 3 parentheses squared plus negative 4 parentheses squared is hypotenuse squared. You are not going to use a calculator for anything in this section, okay? So negative 3 squared is 9 plus that's 16. So that's 25 equals x squared. So x would be 5. So if it wasn't easy like that, a 3, 4, 5 triangle, you could use Pythagorean Theorem. The hypotenuse of any triangle is always positive. Whenever you square any number, what is it always? Positive. So the hypotenuse is always positive. These have direction and length. I went left 3, so it's negative 3. I went down 4 on the y-axis, so it's negative 4. The hypotenuse will never be negative. Are you okay? So the actual question asked for sine theta, cosine theta, tangent theta, and I'll find the other 3 in a second. So in case you've forgotten, we still have so, ka, toa. Okay? So again, theta here is off the origin. This is theta, all right? What's sine mean? Opposite over hypotenuse. What's opposite of theta? Negative 4. What's the hypotenuse of this triangle? 5. If you can simplify or reduce, do it. What does cosine mean? Adjacent over hypotenuse. What's adjacent to theta? Negative 3. What's the hypotenuse of the triangle? 5. Does it reduce or simplify? Nope. What's tangent mean? Opposite over adjacent. What's opposite of theta? Negative 4. What's adjacent? Negative 3. 2 negatives make a. So positive 4/3 is your actual answer. Okay, so in geometry, you're right, we couldn't have negative sides to a triangle. That didn't even make sense, right? We are doing a triangle in the coordinate system, so we can have negative sides because the negative indicates that I went left or down. Do you see the difference? So in geometry, all we could ever have was a 3, 4, 5 like this. This would have been like, oh, just kidding, that doesn't make sense, right? But on here, I'm putting a triangle with direction and length. So the negative indicates that I went left. Does that, or down? Does that make sense now? So you're right. In geometry, that would have been an I can't do it problem, but in Algebra 2 and Pre-Calc and Trig, now you can because it's on a coordinate system. If it was still just a triangle without these tick marks, you couldn't do it. Does that make sense? Okay. Are we okay? It asked us for how many? 6. How many did I give? 3. So I need the other 3. I need the inverses, right? So for inverses, to help you start memorizing them, I always do it the same way. So the inverse of tangent is cotangent. That's easy for me. And then I start to get confused. So COS ends in an S, so I'm going to start with an S. So cosine and secant are inverses. And then the only one that's left, inverse of sine, is cosecant. That's how I do it. You do what you want. I feel like I'm yelling. Am I too loud? Okay. Okay? So when they're inverses, you just flip the fraction, right? You invert the fraction. So if sine is negative 4 over 5, what's cosecant? Negative 5 over 4. If cosine is negative 3 over 5, what's secant? Negative 5 over 3. Right? Sarah? If it's a negative, it's still negative. That doesn't change. It just flips the fraction. You can put the negative wherever you want. The only reason I don't put it in the denominator is because if you ever use a calculator with something like this, most of your calculators don't like a negative in the denominator, and they say something like error or something like that. So I typically put the negative on the top or on the side, but you're not wrong as long as you just have one negative sign. Okay? And then cotangent would be 3 over 4. Anybody have a question yet? You sure? Okay. Example 2, the terminal side of theta in standard position. When they say that, they're just saying do your bow tie or do your axis trig. They're just saying make sure we all draw it the same. Okay? Contains the point 0, 6. So I'm going to graph 0, 6. Alright? Find the values of the 6 trig functions of theta. Again, we're going to find sine, cosine, tangent, and we're going to flip them with their inverses. What quadrant are we in? We're not. We're on the axis. Which axis? The y-axis. Okay? So, because of that, we're going to use this axis trig. We are on an axis. We cannot draw a triangle, right? So this is on the axis, so we use axis trig. Do you see that? So you don't actually use a 6 though, okay? You're going to say it's 0, 1. I know that seems weird. Whenever it's a non-zero number with axis trig, you change whatever the 0 isn't to a 1. So if this was 0, 100,500,000, it's 0, 1. If this was negative 30, 0, it's negative 1, 0. You change whatever the non-zero number is to a 1, or I mean a negative 1 if you were like over here, right? Okay, so that's how you do it. So sine of theta, we got sine, cosine, and tangent. If you memorize it, which you have to, sine is equal to the y value. What is sine of theta here? 1. Cosine is equal to the x value. What is it here? 0. Tangent is equal to y over x. What is y over x here? 1 over 0, which is undefined. You alright? So now we need the other 3, the inverses. Again, I always go in the same order. You do what you want. I remember the inverse of tangent is cotangent. That's easy for me. Okay? And then cosine ends in an S for the shortcut, so this starts with an S for the shortcut, secant. And sine, the only one left is cosecant. That's how I do it, but you do whatever you want. If sine is 1, flip that fraction. It's really 1 over 1, which flipped is 1 over 1 again, right? Cosine is 0 over 1, technically. Flip that. That's 1 over 0, which is undefined. This was 1 over 0, so now I have 0 over 1, which is 0. Once you understand it, axis trig is one of the easiest ones because you just do the formula. You don't have to really think too hard. Questions? Tangent is equal to y over x. So the y is 1, the x is 0. So 1 over 0 is undefined. Anything? Okay. And then when I flip it, it's going to be 0 over 1, which is still just 0. Ready? Okay. Sketch each angle, then find its reference angle. So when we're sketching an angle, it's just like yesterday. What quadrant is 210 degrees in? More people. 3, right? Here's 210. That should be easy. That's just from the other day. Okay? Now we have to find the reference angle. What quadrant am I in? 3. Go to your bow tie. Quadrant 3. And there's my formula, the theta minus 180. So I'm going to take, without a calculator, 210, reference angle, 210 minus 180. And what do I get? 30 degrees. Our reference angle is 30 degrees. Is that okay? Okay. Negative 5 pi over 4. In the next math class that you go to, you probably would keep it that way. But for right now, since it's pretty new for us, let's go ahead and change it to degrees so I know you understand what's happening. So I need to convert radians to degrees. Do I multiply by 180 over pi or pi over 180? 180 over pi, right? Pi's cancel. Now I have to figure that out without a calculator. How many times is 4 going to 180? Say it again. You're close. 45. Okay? Once you get going without using a calculator, very often you'll get quicker, alright? So, I need to take negative 5 times 45. Do you guys know the trick to doing that without like writing all that down? Anybody know a shortcut to multiplying those? So yeah, if we wanted to go back to elementary school, no offense, but you can, right? 45 times 5, you could do that. It's not terrible, but don't do it. Don't do that, okay? Instead, we're going to do a shortcut. We're going to take, isn't 45 the same as 40 and 5? Isn't that 45? So can't I take 40 times 5? And what do I get? 200. Can't I take 5 times 5? And what do I get? 25. So my answer is 225. And it's a negative because it was negative in the first place. Whenever I'm up here at the board doing math without a calculator and you wonder what voodoo magic that is, it's that. Right? Do you guys get that trick now? Sure. Okay. So it's negative 225 degrees. So let's draw that. What quadrant is that in? Negative 225 degrees. Here's negative 90, negative 180, negative 270, negative 360. So it'd be the first, no, it'd be the second one. I don't know why I listen to you guys. Negative 5 pi over 4. It'd be the first one. Sure, yeah, that's right. Look again. Negative 90, negative 180, negative 270 is too far, right? So it's in this third quadrant. It was the third one I did in the second quadrant, excuse me, because I went backwards. This is why I don't record the last class of the day, because I'm like, what? What did I show you? Oh, yeah. Okay, negative 5 pi over 4. So, now we have to find that reference. Are you guys okay? Is that fine? Do you get it now? All right. Now we have to find that reference angle. What quadrant am I in? 2. So on the bow tie, what does it say to do? 180 minus theta. The problem is, if I take 180 minus a negative 225, I'm not going to get anything that makes sense. So those only work for positives. So I need to change this to its coterminal positive angle. Coterminal means, what do I do? Yes, add or subtract 360. If we add 360, we'll get a positive, right? So it's negative 225 plus 360 without a calculator. $135. Okay? So negative 225, or negative 5 pi over 4, is the same as positive 135. Those are the same coterminal angles, I guess you could say. Okay? So now I can do 180 minus theta. I can do 180 minus 135 because they're going to have the same reference angle. So what's 180 minus 35? 45. Your reference angle should always be 45, 30, or 60. That's it. If you get anything else, you screwed up. Reference angle options. By the end of today, you'll see why. It's always going to be, I'll say it in order, I guess, 30, 45, or 60. If it's anything else, we can't do it without a calculator, so that's why. Okay. But if they give me radians, I should probably give them radians. So 45 degrees, I need to change back to radians. So I multiply by pi over 180 or 180 over pi? Pi over 180, so the degrees cancel out, right? We just figured out how many times does 45 go into 180? 4. So we get pi over 4. In pre-calc or college algebra trig, you're going to use some angles so often that you will have them memorized. You'll know that pi over 4 is the same as 45 next year. You won't have to do all these conversions all the time. But not this year. It's okay. Okay? Nope. Find the exact value of each trig function. When they say exact, it basically means don't use a calculator. If you get the square root of 2, leave it the square root of 2. Okay? We need to find the cosine of 240. What quadrant is 240 in? The third, right? I'm going to draw my bow tie. The piece that I need anyway. What is my reference angle, or how am I going to find it? Theta minus 180. So what's 240 minus 180 without a calculator? I'm looking at the wrong one. What'd you guys say? I'm sorry. 60's right. I'm sorry. I was looking at the next one, and then I was doing the math, and I was like, what is happening? Yeah, 60. Sorry, you were right. You're good. Sorry. I was looking at the one below it. I was like, that's not right. You're fine. Okay, so here's how we solve this. If they want cosine, what does cosine mean? Adjacent over hypotenuse. Do I have the adjacent side? Not really yet, right? Do I have the hypotenuse? No, but I can find it. This is a 30, 60, 90 triangle. Okay? Why are you guys moaning and groaning? It is what it is. Across from 30 is a 1. Across from 60 is a square root of 3. The hypotenuse is 2. Every time. No matter how I turn my triangle, those things are always true. Okay? So I always go in the same order. So for me, I started the 30. So here's 30, right? The side across from 30 is a 1. The side across from 60 is a square root of 3. The hypotenuse is 2. Are you okay with what I just did? The only difference between this and geometry is I have direction now. So if I went left on the x-axis, this is a negative 1. If I went down on the y-axis, this is a negative square root of 3. What's the hypotenuse always? Positive. Always positive. Always, 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 always. Okay? So again, what's cosine mean? Adjacent over hypotenuse. What is adjacent to 60? Negative 1. What's the hypotenuse of the triangle? 2. So the cosine of 240 degrees is negative 1/2. Ask me a question. You sure? Somebody with a phone. What time is it? Brianna, what time is it? What is it? Okay, we're good. All right, cosine of 135. What quadrant am I in? 2? So this is my bow tie. You go off the origin into the quadrant, make it perpendicular with the x-axis. Okay? What's my reference angle, or how am I going to find it? If this is 135, what is my reference angle? 180 minus 135, which is it 30, 45, or 60? It's 45, right? Okay? In your 45, 45, 90 triangle, the two legs are 1, and the hypotenuse is the square root of 2. Okay? So this is a 1, this is a 1, this is the square root of 2. They need direction, or they need a sign. What does this one have, positive or negative? Positive? negative, positive always, right? Before today, when we were talking about a 45, 45, 90 triangle, it didn't matter which 45-degree angle you were looking at, right? Today it does, because we have direction. We have negatives on some of them. So this is my reference angle. You have to look at this one, all right? What does cosine mean again? Adjacent over hypotenuse. Take just a moment. Label each of these sides with an O, an A, or an H, an opposite, an adjacent, or a hypotenuse before we figure it out. What's the positive one? Opposite? What's the negative one? Adjacent? What's the square root of 2? Hypotenuse, right? So adjacent is going to be what? Negative 1. Hypotenuse? Square root of 2. You can't leave it that way. Rationalize the denominator by multiplying by square root of 2 over square root of 2. And what do I end up with? Negative square root of 2 over just 2, right? Ask me a question. You sure? Let's do letter D next. It's a little bit easier than Z is. So tangent of 5 pi over 6. Again, this year, let's go ahead and change it to degrees. I think that'll be easier for you. So what do I multiply by? 180 over pi. Pi's cancel. How many times does 6 go into 18 evenly? 3. So 6 goes into 180. 30. So what degree am I dealing with here? 150. What quadrant am I in? 2. You okay? I need my reference angle. If this is 150 degrees, what's the reference angle? 30, right? What side is across from 30? 1. What's across from 60? Square root of 3. What's the hypotenuse? 2. What does the 1 get? A positive or a negative? Positive. The square root of 3? Negative. The 2? Always positive. It's hypotenuse. What does tangent mean? Opposite over adjacent. So what's opposite of theta? 1. What's adjacent? Negative square root of 3. You can't leave it that way. Rationalize the denominator and you get negative square root of 3 over 3. Question? Okay. Lucky us. Option C is 5 pi over 6 again. Isn't that the exact same thing? I have to do it again, right? Cosecant, though, is the inverse of what? Sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. What is the hypotenuse of 30, again, in our triangle? 2. What's the hypotenuse? Or, sorry, what did I say? Did I say opposite? I said it right? No. I don't think I said it right. I don't know if I said it right. I'm sorry. What's the hypotenuse of the triangle? 2. What's the opposite of the 30? 1. 2 over 1 is 2. Sorry, guys. I was literally looking off into space. You said it right. Okay, good. In my head, it was wrong. Okay. Page 811. 4, 8, 16, 18, 22, 24, 26, 30. 4, 8, 16, 18, 22, 24, 26, 30. Anybody have a question? Yeah, for sure.